Please welcome to my YouTube channel. Please subscribe.
Today we'll be talking about a halogenation reaction. A halogenation reaction just talk about adding a halogen to a compound. Yeah, so we can add a halogen to a compound, and such mechanism will result in forming a vicinal dihalide. So let's take for example alkene, alkene, and for that matter, let's take this thing 1 2 3 4. So this is butene. So for this butene, let's react it with a halogen, which is Br2. The halogen always exists as bromine. This one exists as diatomic. So this is it. And let's this one happen to go undergo heterotic fission. So this one will break away like this, and this one will be a positive charge since this one break away. So this one will be the positive charge, and this one will be the negative charge. So let's see how the mechanism goes. Yeah, this is a pi bond here. This one is a pi bond here, and pi bonds, they are nucleophilic. They are rich in electrons, and so nucleophilic have to attack the positive charge here. So actually, we have lone pairs of electrons here like this, and we also have lone pairs of electron here like this. So this nucleophilic will attack this lone pair here. It will attack this one here, and immediately this one have to retaliate. Back and attack like this. Yeah, so when that one happens, so this one is breaking away because this one is taking the bond, so it's breaking away. So when that one happens, we'll form something like this, and since the double bond is between this carbon and this carbon, we will be having a positive charge here, something like a carbocation. Yeah, so something like a carbocation. Yeah, so this bromine have to attach itself to whether here or here. So actually, the mechanism, this bromine have to form a bridge here. This is a bridge. To form a bridge here. So let's say like this, and this is the positive charge. Yeah, so the bromine that broke away, this is how it is. That is the negative charge bromine that broke away. Yeah, so it will attach itself to whether here or here. So we have to take consideration the carbon here. This is a secondary carbon or secondary carbocation, and this one to be a secondary carbocation. So anyway, it have to attach itself to one. So this one, let's say it will attach itself to this place. So when this one come to this place, it will render this bond here to break. This bond here to break. Yeah. So when this one bond break here, you see this bromine attaching itself to this place, and this one have to result in forming a vicinal compound, vicinal dihalide. So we see a compound like this. And so this one is attaching itself to here to form a bromine like this, and this one will stay here to form a bromine like this. And you see, this is another one carbon, and this is another carbon. So this is actually a vicinal compound. Yeah, in these halogenations, we are not supposed to have a germinal compound. The germinal compound is when you have the bromine attaching itself to the same carbon. Yeah, so that is the first example. So we can get an example like this and see. Let's take this a cyclic hydrocarbon here, and let's take it here, put this in here. This is 1 2 3 4 5 6. So this is 1 2 3 4 5 6. So this is cyclohexene. We can do the same bromine there. So use bromine, and bromine will exist like this, something like this, and something like this, because this is the lone pair of electrons. So this one will break away, forming the negative charge, and this one will be the positive charge. In the same way, this is the pi bond, the nucleophilic. So it have to attack these lone pairs, and this one have to retaliate back. So that is the mechanism. So when this one retaliate back, you see that we break this bond here to form alkane. There, to form alkane here like this, and this one and this place will be the positive charge. That is the carbocations here, because the double bond is located here. So this bromine here have to form a bridge between the two places like this. So we have to form a bridge between here. So we have the lone pairs and the positive charge. So the other bromine that broke away, that is the negative bromine, which is something like this. The negative bromine is something like this. I have to count to this side or this side. But here on this secondary hydrocarbon cation, and this one is a secondary hydrocation. So anyway it will go. So let's say this one will attack this place. So immediately we attack this place to render this one to break. So we'll form a compound like this. A compound like this. Yeah, so this is bromine, and this bromine to be here. So actually we have to form a vicinal compound, so we can do this one like this, because this is a cyclic compound. So we can actually do this one like this and something like this, so that we're showing that we are forming um, vicinal compound. So these some examples of this one. Let me give you some to try and see how best you can go with that. So let's take this compound and try our hands on it. Let's say we have this compound, yeah, a compound like this, yeah, and we have a double bond here. So we are doing halogenation, which is just use the same bromine. So bromine. So when you have the lone pairs of electron here like this one break away will give us the negative charge, and this will be the positive charge. So this one will go and attack, like this, since it's the nucleophilic compound. So let's say it will attack like this, and this will attack back. So form a compound like this, we have substituent here. So this is where the positive distance will be, because this is where the double bond exists. So we expect to form a bridge at this side. So form a bridge at this side, which will have the positive bromine here. So we'll have something like this, something like that. So when we have something like this is the positive charge. So the negative bromine, this is the negative bromine, having something like this. So this is a tertiary hydrocation, and this is a secondary hydrocation. So which one will this one bond to? Yeah, so tertiary hydrocation, actually they are more stable than the secondary hydrocation. Yeah, so this one actually have to come to this side. So let's bring this one like this. So immediately this one come, it will render this bond to break. So form a compound like this. We have this thing here. We have a substituent here, and this one will come here. This bromine will come here, and this bromine have to come here. Yeah, to have to come here, but you can the same time bring it like this. See, it's on different carbons, so directly is this a vicinal compound. So this is the mechanism of this of halogenation. You can other use other halogens. You can use chlorine or iodine to give you the same thing. So let's summarize this. So the mechanism: first, the nucleophilic pi bond have to attack the halogen. So the pi bond will break. After the pi bond break in the process, the halogen have to retaliate back and attack, resulting in the halogen bridge. We have to have a bridge here. This is the bridge here. Yeah, so The second halide, this one break away. So this is the one that break away. This is the negative here. Yeah. So the second halide have to return back and attack the bridge here. You have to attack the opposite side of the bridge and break the bridge. So here you consider stability here and do that. This one have two hydrogens. This one have one hydrogen, one hydrogen. These two hydrogens here. This one have only one hydrogen. So even when you use Markovnikov rules, I think this one should attack itself to here because the tertiary cations are more stable than this one. So the product form will give you a vicinal dihalide. So this is it. So I think this is clear and it's okay. Any question you can leave it at the comment section for me. I'll get back to you sharp, and make sure you subscribe to my YouTube channel. Once again, welcome you to my YouTube channel, Chemistry Our World. My name is Halaga Foster. Bye. Meet you.